The topic for Lesson 7.2 is substitution. We'll find out how to solve systems of equations by using substitution and solve real-world problems involving systems of equations. How can a system of equations be used to predict media use? Americans spend more time online than they spend reading daily newspapers. If X represents the number of years since 1993 and Y represents the average number of hours per person per year, the following system of equations represents the situation. Reading daily newspapers, they have y equals negative 2.8x plus 170, and time online, y equals 14.4x plus 2. The solution of the system represents the year that the number of hours spent on each activity will be the same. To solve this system, you could graph the equations, find the point of intersection. However, the exact coordinates of the point would be very difficult to determine without the use of technology from the graph. You could find a more accurate solution using algebraic methods. To substitute means to put something in place of something else. So in example 1, they say use substitution to solve the system of equations. I went ahead and rewrote it using color to emphasize x equals 4y. So then where there was an x, I'm going to replace it with what x equals. So I'm going to have 4 times x equaled 4y minus y equals 75. And now I can just solve for y. So I have 16y minus y equals 75. 16y minus a y is 15y. If we divide both sides by 15, we get y equals 5, and we're halfway there. So now to get our x value, we can go back to our original equation there that was x equals 4 times y, and we just said y is 5. So that means x equals 20. So our ordered pair is 25. Kind of big numbers, but it's okay. Now I'm going to use the second equation to do my check step because I know it works in the first equation. So if I do 4 times the x value we got was 20 minus y we had was 5, 80 minus 5 is 75. So it works in both equations, so I'm confident that I'm right. Since in 7.1 we solved by graphing, I went ahead and put a picture of the graph in GeoGebra because I'm not sure we'd want to do this one by hand. 25 is kind of a ways out there, but it's kind of a nice little confirmation that we know graphically we're right as well. Okay, this time they weren't as nice. They didn't solve for either variable for us. So the easiest variable I have to solve for is this y because there's no coefficient in front of the y. So let's rewrite that. 4x plus y equals 12. So I'm going to subtract 4x from both sides of the equation. And this is what they gave us to start off with in the other equation. Y equals 12 minus 4x. Okay, now that we have an expression for y, I can use the second equation. And now I know what y equals, so where there was a y, I'm going to replace it, substitute in what y equals. So I have 2x minus 3 times 12 minus 4x equals 14. And we get to distribute. So we have negative 2x minus 36. Negative times negative is positive, so plus 12x. Okay, combine our like terms are on one side of the equation, so just negative 2 plus 12 is 10x. Copy everything else down. Add 36 to both sides of the equation in a meta room. So 10x equals 50. Divide both sides by 10. And x is 5. And we had the equation y equals 12 minus 4 times x. So now that we know x is 5, we can just plug that in. And we're going to have y equals 12 minus 20. So y is negative 8. Okay, I know that it works in the first equation because that's when I made it in. So we're going to check using the second equation. So negative 2 times x was 5 minus 3 times y is negative 8, we hope equals 14. Negative 10 plus 24 is in fact 14. Smiley. So order pair is 5, negative 8. Which, again, looking at the graph, nice computer-made graph, is the same as where the two lines cross. We like it. Again, same directions. It says use substitution to solve the system of equations. And I decided to solve for y in the second equation. No reason, just felt like it. So y equals negative 2 minus x. And I can go to my first equation. I'm going all Americana here, red, white, and blue. So we have 2x plus 2y equals 8. So where there was a y, I'm going to substitute in what y equals. So 2x plus 2 times negative 2 minus x equals 8. And once again, we distribute. So we have 2x minus 4 minus 2x equals 8. Combine our like terms. Ooh, 2x minus 2x is no x. Houston, we have a problem. Negative 4 does not, in fact, equal 8. Rats. And we ran into this already in the last lesson. If the lines don't cross, we said they were called inconsistent. So there's not going to be a solution. This is a no solution problem. I pondered this one for a while. There's not a really nice variable to solve for. Everything has a coefficient. So I guess I'm just going to solve for y in the second equation just because it's easy for me to write under. No better reason than that. So I'm going to add 6x to both sides. So I have 4y equals negative 6 plus 6x, and divide both sides by 4. Ew. So y equals, I guess, reduce the fractions. So 6/4 would be 3/2. So now I can go to my other equation, and where there was a y, I'm going to substitute in what y equals. Ew. But it's not so bad because our 2 is going to make the fractions go away anyway. I won't cry too much. Okay, so we have 3x, negative times negative is positive, so plus 3, so those 2's will cancel out, and that 2 will cancel out. We minus 3x equals 3. Oh, so once again, the x's drop out, but this time I have 3 equals 3, which in fact it does. I don't know if you can tell, but I actually did try to use colors here. I graphed the first line in blue and the second line in red, and red and blue kind of should make purple, but it just looks like red. I tried. But GeoGebra really said I'd graph both lines. See, look, there's B, there's A. It's the same line. And we said in lesson 7.1, it's a system that's called dependent. And here, any point that is on one line is on the other line because they are, in fact, on top of each other. So there are an infinite number of solutions. Infinite. Haha. Ooh, that's really ugly. There are infinitely many solutions, even if my infinity sign is really sad. In a system of equations, to solve by substitution, you're going to solve one equation for one variable if they don't give it to you that way already, then substitute that expression into the second equation to solve for both x and y, or a and b.